Okay, Assalamualaikum semua. Jadi saya akan teruskan application of triple integral, that is mass, moment of mass, center of mass, centroid dan moment of inertia. Okay. Okay. So moment and center of mass. Moment and center of mass for triple integral. So please recall back for double integral also in my PowerPoint. So your density can refer as delta, that is function of x, y, z. Okay. So your density is mass per unit volume. And then your mass will be triple integral under surface G, density times dV. Okay, so G is the region of the solid and dV is the change of volume. Okay, so moment of mass. Will be moment at yz will be triple integral G into G x times z dV. Okay, so moment xz will be triple integral G y times del x yz times dV. This is xz. And then moment of xy will be triple integral gz times the density dV. Okay, so your center of mass x bar, y bar, z bar will be myz over m, mxz over m, this m, and then mxy over m. Okay, it's a coordinate. So centroid. So the centroid is measured when the density is constant. Is constant. Okay, it's x bar, y bar, z bar. Okay. So this point we'll call centroid. So remember that volume for triple integral will be integration 1 dV. Okay. Okay. Okay, for moment of inertia, of solid about x-axis, inertia about x-axis will be triple integral under surface G y squared plus z squared times with the density times with dv. Okay, not times, is integration y squared plus z squared times with the density respect to dv. Then moment inertia about y-axis will be triple integration at G plus z squared x minus z dv. Z will be triple integration of G under G x squared plus y squared del x z dv. Okay, so pretty similar with the double integral. Okay, we go to the example 1. So example 1, find the centroid of a solid of a constant density delta bounded below by the disk x squared plus y squared less than 4 in the plane z equals to 0 and above the paraboloid z equals to 4 minus x squared minus y squared. So you have to highlight that. You have to understand what is meant by bounded below by and above the. Okay. Okay, we try to sketch first. We try to sketch the region. So bounded below by the disk, which means below the region is bounded by circle, or bounded, or means above the circle. Okay, bounded below means above the. Okay, bounded below by means above the. Okay, which means is exactly above the surface. Okay, also and vice versa. So first we try to sketch. So x squared plus y squared. So it's just a circle. Z is missing, so it will project to z-axis with radius 2. So we will get a cylinder in 3D. Okay. So another one is z equals to 4 minus x squared minus y squared. It's a paraboloid. The maximum value is 4. Okay. So we have to combine the two surfaces. So first we try to sketch xy plane to know the region of xy plane. First to know the region of xy plane. So xy plane will be the circle, right? Okay, just draw it first. Circle. with radius 2. Okay. Okay. So this is y-axis symmetry. Then for z equals to 4 minus x squared y squared, xy plane, where we refer xy plane of circle, we see that the x is between -2 to 2. Okay, and y also -2 to 2. Okay. So we can let z equals to 0. So when z equals to 0, we have x squared plus y squared equals to 4. If this z equals to 0. Okay. Again, you have a circle base with radius 2 and -2. So how about xz plane? So xz plane y0, we have z equals to 4 minus x squared. So this is just a parabola. And then when z equals 0, x is -2 to 2. It's a maximum curve, sorry. It's a maximum curve. Also for yz plane, when x is 0, you will get the same. So you will end up somehow is like the base is circle, and then this is z xy, zy and zx both are parabola. So this is for zx and zy. Okay. Okay. So they ask you to find the centroid of a solid. So I take another sheet. Okay, another paper. So Z bar. So by symmetry, your x bar equals to y bar. So we need only to find z bar. Okay, remember this concept. X bar by symmetry x bar equals to y bar equals to 0. So we need only to find z bar. So z bar is mxy over m. Okay, let's see, right? See. So your z bar will be mxy over m. So your mxy from the formula, triple integral on the surface G, z times with the density dV. So you can use the cylindrical coordinate because the solid involves the circular base. It is easier for us to solve triple integral when involving circular base using cylindrical. So your mxy, okay, we have z times with the density, and then we have r dz dr d theta. So your integration, okay, for theta your base is disk, is a circle, so 0 to 2 pi. Okay, your radius is 2. Okay, 0 to 2. 0 to 2. Radius always positive, so 0 to 2. So how about Z? So they're giving you okay, how about for Z limit? So from here you have Z equals to 4 minus x squared minus y squared. So you can write as Z equals to 4 minus x squared plus y squared. So x squared plus y squared is r squared. So it is from 0 to 4 minus r squared. Okay, from 0 to 4 minus r squared. Okay, so since your density is a constant, we can put outside of the integral. So your mxy will be del xyz. Okay, integral of 0 to 2 pi, 0 to 2, so integrate z will be zr. Okay, you will get r z squared over 2 from 0 to 4 minus r squared dr d theta. Okay, so further you will get mxy equals to, okay, try to do it yourself, you will get 32 pi delta over 3. Next, to find the centroid, you have to find the m also, small m. Okay, big M and a small m. The big M is the moment and small m is the mass. So for the mass, the formula is triple integral under surface G times with the density dV. So this could be easier, 0 to 2 pi, 0 to 2, 0 to 4 minus r squared. Okay, del xy is a constant, and times with dv, that is z r dz dr d theta. Okay, so if you solve this, you can take out the delta, you will get 8 pi delta. So this delta is the density. So your z bar now, mxy over m, (32 pi delta over 3 over 8 pi theta, that is 4/3. So your centroid x, y bar, z bar is equal to 0 because of symmetry, again 0, symmetry, 4/3. Okay, so please try to integrate by yourself. Okay, also this. Okay, also for big M. Okay, big M and small m. Okay, next example. So see your slides. So next example will be on tetrahedron, Cartesian coordinate. A solid is the tetrahedron bounded by coordinate plane x plus y plus z equals to 2 if the density equals to 2x. Find the center of mass. Yes. So as we know, we have to find x bar, y bar, z bar. So the formula is myz over equals to over m xz over m, and mxy over m. So this is z coordinate, y coordinate, x coordinate. So I think it's easy to remember. So find the alphabet that is missing. So x is missing here, and this is y is missing. So that's why this is belong to y coordinate. This is z is missing, so belongs to z coordinate. Okay. So first we try to sketch. I think this is so easy to sketch. So for xy plane, z equals to 0. So you have x plus y equals to 2. So when you plot this, when x 0, y is 2, y 0, x equals 2. Okay. So this is for y with this x. Then xz plane. So when y is 0, this is equal. So x plus z equals to 2. Again 2 2. This time z x. So y z plane, x equals 0, y plus z equals to 2. So you will end up with 2 2 again, but this is zy plane. Okay. So you will end up with tetrahedron. So 2 2 2. Okay. Okay. Z axis, axis, x axis. So z equals to 2 minus x minus 1. Okay, this will come from the original question. We already know the z, so we can use the Cartesian coordinate to solve the integral. So myz, okay, myz will be triple integral x times with the density function, that is 2x, okay, dz dy dx. Okay, we use type 1. Okay, dy dx. Okay. Okay. Remember, for type 2 here will be y, type 3 here will be x. Okay, this can be changed, dx dy or dy dx. It's okay. So if I consider dy dx, which means I choose this region. Okay, so this is 2, 2, 0, and this is x plus y equals to 2. Okay, so if I choose dy dx at the behind, at this region, so which means I will cut at x. Okay, I will cut at x. Okay, your x will be from 0 to 2, 0 to 2, and then your y will be from 0 to y equals something. So this is y equals to 2 minus x. So put here 2 minus x. Okay, and then your z, for sure it is from 0 to the surface. So this surface is z equals to 2 minus x minus y. Okay, so if you integrate this, you will get 16 over 15. Okay, okay, so actually you can use any type. So this is type 1. Okay, you can use type 2 or type 3. But you have to choose the correct region. But in this case, all regions have the same line. Okay. Okay. Next, you have to find for xz. Mxz will be triple integral under g y times with the density function, okay, times with dv, okay, from the formula itself. Okay, next this is xyz. So density function given by 2x. So we can use the same thing. You can use the same thing, type 1. So this is from 0 to 2, 0 to 2 minus x, 0 to 2 minus x minus y times with 2x. Your dv is dz, dy, dx. Okay. You can fix with type 1. Then, if you solve this, you will get 8 over 15. Okay, try to check, do it by yourself. Then for eight over 15. So myz, mxz, then mxy will be triple integral under g x times with the density, again type 1. Okay, so this is 0 to 2, 0 to 2 minus x, and 0 to 2 minus x minus y, 2xz, here will be z, sorry, 2xz, dz, dy, dx. Okay, so again you will get 8 over 15. Okay, so next you have to find the m. Okay, to find center mass, you have to find the small m. The small m, you can use the same limit 0 to 2, 0 to 2 minus x, and 0 to 2 minus x minus y, times the density, and dz, dy, dx. Okay, so your density is 2x. So if you integrate this, okay, you will get 4 over 3. So your center of mass now, your center of mass will be x bar, y bar, z bar equals to 16 over 5 over 4 over 3, 8 over 15 over 4 over 3, 8 over 15 over 4 over 3. So it is 12 over 5, 2 over 5, 2 over 5. Okay. Okay, next, moment of inertia. Okay. 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 Question 2 in your notes. Find the moment of inertia of the ice cream cone G cut by the solid sphere at rho equals to 1, less than 1. Find the moment of inertia. Find I for moment of inertia of the ice cream cone G, ice cream cone ice cream. Cone G from the solid sphere, rho which is radius less than 1, by the cone from the solid sphere, by the cone. Cut from solid sphere when rho less than 1, by the cone when phi equals to pi over 3 about z-axis. And take the density equals to 1. Okay, again, find the moment of inertia of the ice cream cone cut from the solid sphere, rho equals to 1, radius equals to less than equals to 1, by the cone at phi pi over 3 about z-axis. Okay, so if you want to sketch, you can find the r and z. So let's say I have a cone. Okay, so the phi always come from positive z-axis. Okay, and this is phi equals to pi over 3, and this is r, and this is the rho. Okay, this is the rho. The phi inside is pi over 3 from z positive z-axis, and this is the r. This is the rho. Okay, so your phi equals to r over 1. This is right angle triangle. So your r is 0.866. Cos phi will be z over 1. So your z will be 0.5. Okay, so put the value back. So which means you have a graph. So I just focus on z, and this is negative 0.8860 and 0.8660. Okay, and then you have a cone, and inside you have a cone inside a circle, and this is 0.5. And then phi is pi over 3. Okay, actually the 0.8 is here. Sorry, it's not here. Okay, it is here. Okay, so from this curve, theta is from 0 to 2 pi. Phi is from 0 to pi over 3. Your rho is from 0 to 1. So this is spherical question, spherical coordinate. Okay, so we have to use spherical coordinate. So they ask you the moment of inertia at z, which means triple integral g x squared plus y squared, you have to remember, times with the density dv. Okay, so let me draw again. You have a cone. I just draw the in front part. You have a cone, Okay, inside is a circle, so they give you that this is pi over 3, this is 0.5, then you will get the x-axis, the horizontal axis will be 0.866, and this is negative 0.866. Okay, so this is ice cream, so you can draw okay. So to continue this, so IZ, to continue the IZ will be, so remember your x is rho in cylindrical coordinate, rho sine phi cos theta, y is rho sine phi sine theta. So your IZ will be 0 to 2 pi d theta here, and then 0 to pi over 3 is the d phi from z axis, and your rho is 0 to 1 d rho, and then we have sine phi here, rho square. So the inside one is x squared plus y squared, so x squared plus y squared. So your x will be rho sine phi cos theta, your y will be rho sine phi sine theta. So you can write this as 0 to pi 2 pi, 0 to pi over 3, then 0 to 1, rho squared sine squared phi. You can factorize cos squared theta plus sine squared theta, rho squared sine phi d phi d rho d phi d theta, and then this part will be rho 4 sine cube phi. Okay, so you integrate this, you will get pi over 12. Okay, that's all. So next we will move to chapter 4, that is vectored valued function. Okay, see you again, bye.